Okay, hello again. Now from my side, I will talk a little bit of the EV parts of the rules. So what has changed and why it had changed. And yeah. So one of the first rules that have changed is the EV 1.2.2. It hasn't changed. There's only one clarification. So what is a high current path? And already some team members asked me, yeah, but what about gate driver current? What about ECU current and so on? No, it's quite simple. Only the RMS value is in focus of this rule. So if you have some pulsed gate drivers with a few amps, it doesn't matter. That's not the high current path. Also, it's only the tractive system current. So for your cooling fans, for your DV ECUs, for your inverter power supply, the low voltage power supply, that's still normal rules. So there are no high current rules applicable. So, and the next very big change, where is very much rumors, is the rule EV 3.1.3. That's about grounding. You have to, so especially the 100 milliohms. Yes, it's a tough rule. It's not so easy to get this 100 milliohms, but you have to keep an eye on EV3 on the rule before. There is defined what have to be grounded. So you don't have to have this grounding through the whole car. Only firewall, inverter housing, tractive system housings, and other stuff that's mentioned in the rule before is needed to have this 100 milliohms. And the next thing is the measurement point for the low voltage ground is not the grounding point from your car. You can define where's your grounding point. When you say it's exactly there, then it's difficult. But if you say your main hub is your ground, then it's quite easier, because for EMC reason, I would suggest you put all cables to one grounding point and connect everything there. And from this point, there will be the measurement. It's quite easy. It's quite easy to have it done by the measurement point, but there will be some methods to do this in Austria, that we measure it to your grounding point. It would be nice if it's accessible. If not, you might lose quite much time in scrutineering. And at least for FS4A, I can promise you there will be no team that's not driving because they can't reach this 100 milliohms. There will always be a solution. If the team is happy with the solution, is another topic. Yeah, another small change is about the RMS voltage, the 600 volt voltage. Till now, it was in the rules allowed to have it in the inverter a little bit more than 600 volts for the gate signals. Now there's also this exemption for the AMS. It is important to don't have any, to never have more than 600 volts at the accumulator connector, not at the data logger, because more than 600 volt at the data logger will be a DQ. So always be careful about your braking energy. Yeah. We also changed the clearance and creepage rule a little bit. For the creepage path, for the clearance, to have a better clearance, you can now cut your PCB, but always be careful. You have the creepage path over the chip also, and you can't cut the chip. So normally this won't work. So just do coating if you can't reach the distance. And with the coating, you get to the 4 millimeters, and it's quite easy to get the 4 millimeter chips. The next big topic, FF4 was banned from stacks. This was a little bit, not so intended as it is now. There will be a rule change in the version 1.1. It's about, we had it in 2 years ago in FS Austria, last year in Germany. There are always teams that stack their accumulator PCBs. They have one PCB, then over there's the cell tabs, and over there's the bus bar. And all second with one screw, and the PCB will bend a little bit, and then you have the force only at one point of the bus of the cell tabs, and that's simply not allowed. That's simply not okay. That's a safety issue. We didn't let the team thrive with this solution, so they spent the week by rebuilding the accumulator, and yeah, that's not funny. That's not how it should be, and so there will be the rule a little bit relaxed. So if you have really a stack with FF4 in it, it will be allowed, but there will be restrictions. So there are also some clarification with the directive system measurement points, especially soldering. So as I did it when I was in the team, and I saw it at many teams, is to solder the wires for the measurement points directly to the measurement points. They are not built for this. That's not working really good, and with flexing, it will break. The measurement points are you need them immediately because that's your last line of defense. When you don't know, is it the car working or not, the taser is broken for some reason, then you have to have something where you can measure it. And there you need the measurement points, so they're really, really important. The same for the T-cell. They are very much, they're very important. So when you have connectors, because you have the measurement points, they invert in the housing and something like this, the connector must have an interlock. So if you forget to connect it, the car will not start, mostly. And and at the measurement points, the best solution is a wire lock and a lock nut. There was a rule that spare directive system accumulators must have the same dimension and weight and type as the original accumulators. This was deleted. This means basically because that there are no spare containers allowed anymore. The simple reason is we have not seen it anymore at the team. So nobody built a second container just for fun, and so this rule was deleted. You are now only allowed to have one container at the event. But still is allowed to have multiple containers, so to have one container in the front and one in the back, or one on the right side, one on the left side, or something like this. That's still allowed. But you have all of them shown at the accumulator inspection, and they all must be built in the car at the same time. For the accumulator indicator, the last 2 years, it got modern. We saw it that the indicator light was flashing at some teams. And you saw it clearly, it was not intended that it's flashing. It's just the team built it and it started flashing because they did not proper cooling for the chip, for the LDO chip or for the buck converter. It got hot. It turned off because of over temperature. It cooled down a little bit and it turned on. And so we had a flashing of 1 hertz or ½ hertz or something like this. And we said, no, that's not okay. The LED must now light the whole time. it must be on a constant level, no shimmering, no dimming. And it's also possible with the Viper 06 that some teams use for this application, and it works fine. You just have to know how to do it. Yeah, the last few years we had to accumulate segments for the SCS and sections for that you don't have to more than 60 volts, 130 volts, or 6 megajoules. This is now combined to one thing, so you have to. Most teams had always like this. There are always some teams with special solutions, and it was always arguing. So nowadays we have segments, maximum 120 volts or 6 megajoules, and between these we have to have these firewalls. Now they have to go up to the ceiling of the container, so the whole time. But 25% of the of these walls might have holes. Okay. Also, a small clarification about the AMS laptop. So, according to the rules, you must have a laptop or a device to read out your the status of your battery, of your high voltage battery. So, temperature and voltages. Most teams use a laptop, and there are always, every year, 1 or 2 teams that have a laptop but no battery. Battery is broken, battery is down, it's an old laptop, they found somewhere, they use for this. Just use the laptop of a student for this, from the ESO or something like this, with a working battery. You must be able to read out the voltages during testing, during the endurance. If there's an AMS error, you have to know what is the problem, and then you need your laptop. Or you have some other kind of device, some tablet, or you can do it by Bluetooth with your phone. That's all suitable, but it has to be mobile. There's a new vendor, IMD, the ISO 175. Quite nice part. It has a CAN interface. With the CAN interface, you can read out the voltages and the isolation resistance. Really nice if you use it. With this CAN interface, you also can change the response value. Don't change it. It won't help it because it won't help you, because we will measure the IMD response value after the event, after the endurance, after the acceleration, and so on, especially when it's raining. And after the rain test, clearly, we will change to test it with the resistance you need. So, yes, you can change it. The problem is when we find out that teams will change it for some reason that won't help them. But if you do it, we will block the CAN interface, and then you are not allowed anymore to read out your resistance. Would be nice for logging or whatever you want. So just don't do it. Yeah, diesel screen light must be available at the accumulator charger. This is basically because we want to change the process of scrutineering. We strongly recommend you to insert all the signals, all the logic for the green T-cell inside the accumulator. It's definitely allowed by the rules, and then you don't have to do very much at the charger because you just have to implement one LED. Yeah. If you want to have your logic in your car, then practically you have to do the same at your charger, the same logic, and we will test it. So We will open the stacking error detection and have a look if the error is pending or is latching. So the error LED error status is latching. We will do some different voltages between the input and the shutdown circuit. So everything that's in the rules will be tested in scrutineering next year. So keep your logic in your accumulator. Maybe have connectors to disconnect the airs, just that we can check if there is a stacking error detection working, and or if it's not working, then yeah, then it's not okay. Yeah, that was the changes in the EV rule. It was not so much. Are there any questions from here or from Slido?
Yeah, there's a lot of questions, so let's get to it. So first question is regarding the indicator. Could you clarify if using a digital voltmeter powered by an isolated flyback converter complies with rule EV5410? Since the question references that the voltmeter is purely built in hardware, so it should be valid.
It should be okay as long as this DC-DC is only hardware and is not backed up with software, has no microcontroller in it. But why should I do this? So I think it's allowed. I think it's okay. It always depends on the implementation. But I can, as I understand the question, I can't see why it's not allowed. But yeah, yes, it is allowed.
Can TSAC have cooling holes on the structural wall facing the driver, so through the firewall, if it has ducts made out of fire retardant material that is mounted on the same wall and redirects holes to the sides away from the driver?
That's always a question of definition. When your ducts are parts of the TSAC, it's allowed. So if they are always mounted, if they are glued or something like this, then they have to be from material that the TSAC can be, so fire retardant material and so on. So if you do it the right way, yes, it is allowed. If you do it the wrong way, it's not allowed. Quite simple.
Okay, next question. Is a thermal simulation of the battery pack required for the tech inspection?
No. Quite simple, no.
Okay. Does the change of the rule EV722 wants to keep the relay arms the relay disarmed if the STC is closed again, or is it okay to arm the relays again and control the charging process with software?
We mainly synchronize the rules for the car and the rules for the charger. So it's the same as in the car. If you press the shutter button and you release it, till now it was allowed that the charger will start immediately. Now you have a dedicated, you have to have a dedicated start button. So when the shutter button is closed, everything is closed, then you can press this start button and it will start up.
Does the T-cell on the charger need to comply with only EV4103, or has it to comply with all the rules of the green light in T-cell?
I think the EV4103 are the rules about the T-cell. I'm not sure now, but normally yeah, EV4103 are the rules for the green T-cell. So I don't know. I don't understand the question.
Oh, okay, maybe we'll sort it out later in chat.
Yeah.
Is a soldering nut, hot melt nut, okay to be used for screwing in the maintenance plugs?
I don't know what a soldering nut is. Do you know?
I think this refers to hot melt nuts, which you can use to make a metal insert into like a 3D printed part. And you put that basically on top of your soldering iron. It heats up, and then you can push it into a 3D printed material.
Yeah.
But this is not soldering in the context of it's a soldered connection, which is not allowed in the high current path. I think this is the background of the question.
Okay.
So it's not soldering, but it's also not like a proper type of mechanical connection for bolts.
I don't know if you want to fix the bolt and there's only the function of the bolt, and then otherwise it would be fly around. In my opinion, it would be okay, but there are much better solutions. So
Yeah, maybe this is also one of the issues where it might be best to actually mail us a rules question with a picture or screenshot of your design.
Would be better, yes.
Okay, what counts as a wired connection on an accumulator temperature sensor, and where you have to be able to disconnect it in the scrutineering?
A wire connection, if you have THT sensors, then it's always a discussion. If they are very short, then they sometimes say it's okay, but normally that's already a wired connection. If you have cables, that's clearly a wired connection. When you have an SMD part and you press the whole PCB on the cell or on the bus bar, and the AMS chip is on the same PCB, so there's only wiring through the PCB. Then it's not a wire connection. And where to test it, you have to simulate a broken wire. It is okay to have tip switches on the PCB. When you open the tip switch, then it's the same. So when you route, you have a connector soldered your wires in, then you route it to the tip switch, and then you route to the AMS chip. This will be completely fine for me. You can also insert a Zwischen connector, so that you connect all your temperature cables, open this connector and put some PCB between with dip switches just for scrutineering to show a broken wire. A single broken wire will lead to an AMS fault. That would be fine for me. Yeah.
So an intermediate PCB for testing.
Exactly. Intermediate PCB for testing. Exactly. That's also something you can do at the brake on the accelerator pedal. Also, there's sometimes better to have an intermediate PCB than to work inside the car.
Will there be again a 30 milliamp RCD in FS Austria 2025?
Yes.
Do you care to elaborate?
No.
What is an RCD value for us non-electricians?
That's the FE in German,
Okay.
and 30 milliamp are standard for households, and so it's a standard RCD. There are special RCD for industrial environments. We don't have an industrial environment, so we need to have the 30 milliamp RCD. Quite simple, we will have a 30 milliamp RCD.
So if your electrical equipment triggers this circuit breaker, then you will have a bad time. Sorry about that.
Yep.
We can't change it. It's just not allowed. Okay. Can the electronics compartment of your TSAC be made out of electronically insulating material, while the rest of the segments are made of metal, so are electrically conductive?
Basically, I would say yes, but make your rule questions with your pictures. What you really want to do, because but you can, everything that's electric conductive must be grounded. I think it's getting harder for you if you mix this up, but make your rule questions.
I think it might be possible or easiest if you have like actually compartments which are sealed by itself, and you'd say, okay, this is an actual electronic box, and you have like a cable running in between. but this is not possible for some parts of the accumulator, right?
Yeah, that's
Yeah.
make a good question.
Yes.
Question.
Okay, so this is about the mechanical rules for the accumulator. The fasteners of non-structural parts, like the AAR, they do not have to follow the rules with regards to the size of the bolts, which is T1012. Can hexagons... I already answered that. So there is quite a lot of rules about safety fasteners, which is the chapter T10. In this case, we allow small fasteners to be used in any kind of application, but it still has to be like a socket head cap screw or a hexagonal type bolt, because these are the only type of bolts where we say we can properly check them and these are proper fasteners. Is answered. Green teaser light during charging, EV7.9. Should the teasel include the latching? We don't have the teasel logic implemented inside of the accumulator, so could you please clarify?
Yes, this should include latching. This should include everything as in for the green teasel. And as I said already, you will have a better life at scrutineering when you're including this in your accumulator.
EV 3.1.1. Can the accumulator be constructed of multiple different materials? So this is basically the same question as before.
No, if there can be a stack.
Yes, but it is still about, so the rule EV 3.1.1, it says you can either make your whole accumulator out of non-conductive materials. So typically speaking, this would be a laminate out of glass fibers or with aramid fibers. Of course, in that case, everything is non-conductive, and if there is like some kind of shortcut, everything is isolating, so there is no issue. As soon as you start having metal parts, so conductive parts in the accumulator, everything has to be conductive and grounded.
Yeah, but the inner side of the accumulator must be isolating. So basically, you have to have conducting and non-conducting layers in one stack, in one stack, and so the inner side must be non-conductive. And if you have some conductive metal in the outside, it's up to you, but it has to be grounded.
I suspect that the background for this question is a very specific design, and also here it would be best if you just submit the rules question with a screenshot of your design so that we better understand it. Penultimate question. For the accumulator SCS, in order to measure the height of the panels, how should you take the measurement if there are holes for ventilation? I think this refers to the panel height, which is basically with regards to the structural integrity. So if you have like a wall, do we have like a chart? Haben wir Kreide? Okay, sorry, we have nothing to draw. But for mechanical purposes, you have to use the... thank you.
Hirte, kannst du die Kamera ein bisschen dran?
Get this. So, if you have your accumulator, basically, in this case, we have a section view. You have your stacks here. And here on top, you have some kind of bus bar and your wires and whatever. Then I guess you will have an opening here, shaped like this, probably, in your internal wall, which allows for the passage of your bus bars and also for your cables. And I guess like here, for example, like this. you might have some holes for ventilation. Of course, with regards to how many holes you can have with regards to the 25% rule, this light here, this and this are holes, and this area must be below 25% of the whole area. And the whole area goes until the top of the container in this case. This is the new rule. And now with regards to the mechanical and how to implement it in your SES, you have to take basically the section which is the weakest point, which is right here, and the remaining panel height, which is this value plus this value. This is the panel height which remains with regards to your structural equivalency, and this is the panel height that you put into your accumulator SES for the structural documentation.
Okay, I think I can answer this. Yeah,
yes. So we have one question with regards to EV 3.1.3, which is regarding the 100 milliohm requirement for grounding. This appears to be impractical to achieve, particularly in areas such as screws around the TESAC housing. How strict is this rule going to be enforced at FS Austria?
As already said, no team will not drive because they can't fulfill this rule. There will be other solutions, but you can fulfill it. You can use quite thick wires. That's possible. Also, yeah, this is not impossible. If you have only very, very thin wires, then it's not possible, but you have to use thicker wires and proper grounding, then it's not a big deal. Also, you have to have the 10% of the accumulator fuse, so your wires must be able to carry 10% of the accumulator fuse current, and from this, when you have this thick wires, there is no problem. So
I just saw one more question which is related to electrical.
okay.
It is about the electronic. Yeah, so it is about electronic throttle. Of course, this is with regards to combustion cars. The question is, we have one sensor and it has multiple output wires. One of those wires gives like the normal signal and another wire gives the inverted sensor signal. Are we allowed to use the inverted sensor signal as the second required sensor? Answer is a clear no. It says you need to have two signal outputs which have non-parallel and non-intersecting variables. So if you have we're talking about two sensors. You have your throttle position in percentages from 0 to 100. And you have typically your voltage for the sensor. And you need one sensor which is like this, for example. And you need a second sensor which goes, for example, like this. And the reason behind it is that at no point of the throttle position do you have an intersection between the two signals. At every point you can tell, okay, this sensor should be here, this sensor should be here, the signal is okay. And when the other thing would be, like you are trying to propose, that the second signal is like here in green, then you have one point where both signal outputs are exactly the same, and the system cannot tell if actually both signals are still working or there is a shortcut between the signals and both signals are the same because of the shortcut. So no, this is not allowed. You have to use 2 actual sensors, but there are some sensors which in one case have 2 signal outputs which are non-intersecting, which allow this.
That's the automotive standard, so there are quite much of these sensors available on the market.
Yeah. Okay, as of now, I cannot see any more questions. Maybe right now I will overtake the room and see if some of our on-site participants have some kind of questions. Don't worry, you won't be in the video. We won't see your beer. But yeah, maybe I think most of you here are teams with electric cars. And I guess you have some questions. Do you care to ask them now?
I asked already online.
Okay, so you don't have any more questions? Because we have to bridge some time. Maybe the guys from Vienna. Oh, they are so shy. Again, you are not on video, you will be anonymous. Okay, then in the meantime, I can see if there are some more online questions which I can answer already, because our next block will only start at 4 o'clock sharp.
Ja, machen wir Pause.
Yeah, let's see. I think there have been some questions with regards to accumulator documentation. Yes, this one here. Okay, my moderator told me to just make more breaks. The next session will start at 4 p.m. We will have two streams in parallel to each other. So the main stream right here will be about cost report, and the secondary stream where you can find on the left of your Slido interaction sheet, which I can. Yeah, I should be able to find it. If you found the first stream, you will be able to find the second stream as well. There has been a small change in the background, so click the link again. It is a new link now. And on the secondary stream, on the secondary live stream, there will be the business presentation event. Yeah, so next session, statics, in 20 minutes. See you there. Until then, we make a break. Thank you.